Let's explore Persephone's real-time sequence alignment tools. To begin, let's open the first chromosome on a reference genome of maize. Take a look at this track called seq tags. As you can see, this is a marker track where the markers were artificially generated by cutting out equidistant pieces of the sequence, 200 nucleotides long and 20,000 nucleotides apart. As a matter of fact, this was done using a command in Persephone Shell, Persephone's back-end loading and analysis tool. Afterwards, Persephone Shell mapped these sequence fragments across the other genotypes in the maize pangenome. As the result, we can click one of the markers and see every place in the pangenome where it scored a good match. For example, this marker matched a location in CML 277, so let's take a look at its match by clicking the eyeball icon next to it. We can line up the two locations by right-clicking the marker and selecting Align Connected Features from the pop-up menu. Let's zoom out a little to see the bigger picture. It looks like most of the sequence fragments matched up, but not all. Let's use the Minimap 2 tool to get a more fine-grained picture. To do so, click this blue arrow in the upper left corner of the map. Persephone will then run Minimap 2 to align the complete sequences visible on screen, using the bottom map as the query and the top one as the subject. In this picture, direct matches between sequence blocks are shown as blue ribbons, and inversions are shown as red ribbons. Currently, the picture is a little messy, but we can clean it up. Let's right-click the blue arrow and choose Filter Results from the pop-up menu. The first thing we can do is directly edit the command line parameters to Minimap 2. Some of the most common parameters are collected in a pop-up form under this button, and we can edit them visually. For example, we can increase the minimum chain size to prefer longer ribbons and enable secondary alignments to show potential duplications. But if you are familiar with Minimap 2, you can also edit the command line directly. After adjusting the parameters, click the Refresh button and explore the new results. Your most recently used parameters are saved to your user settings, and you can click this button to reset them to their default values. But instead of editing the parameters and rerunning Minimap 2, we can also post-process the existing results in real time. You can use this slider to hide all ribbons that are too short or too long. Note that the histogram above the slider shows the distribution of ribbon lengths. You can also choose to show only collinear ribbons. This next slider controls the maximum allowed angle, hiding all the ribbons that extend too far out to the side. As before, the histogram above the slider displays the distribution of ribbon angles. Finally, you can use the slider at the bottom to join smaller ribbons together by covering up the gaps between them. Note that as you adjust these options, the readout at the bottom displays the number of ribbons that are currently visible out of the total number produced by Minimap 2. To explore the sequence alignment in even more detail, zoom in to about 1 million BP so that the green arrow button on the left becomes enabled. Click the button to run BLASTN between the two sequences, once again using the bottom one as the query. As before, you can adjust the command line parameters directly or post-process the results. Note that the bright red lines at the edges of the ribbons indicate insertions or deletions. You can zoom in, down to individual nucleotides to examine them up close. Finally, to clear the results, right-click either one of the sequence alignment buttons and choose this option from the pop-up menu. By the way, in the latest version of Persephone, you can choose to render the ribbons using smooth curves instead of straight lines. To do so, open the Settings menu and turn on the Draw Curved Ribbons option. In this mode, you can also double-click a ribbon to zoom both of the connected maps to fill the entire screen.